Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we're going to discuss another problem. This problem is about dot product of two vectors and cross product of two vectors. So let me start the lecture. 1 minute. I have to connect this. So let us start. Let me give you today's problem. Then we will move toward a solution. So today's problem goes like this. We use this color. A certain vector A in the xy plane is directed to 50 degrees counterclockwise from the positive x-axis and has magnitude 7.4 units. Vector B has magnitude 5 units and is directed parallel to the z-axis. Calculate part A, the scalar product A dot B and part B, the vector product A cross B. This is our today's problem. So let me check the problem. A certain vector A in the xy plane is directed to 50 degree counterclockwise from the positive x-axis and has magnitude 7.4 units. Vector B has magnitude 5 units and is directed parallel to the z-axis. Calculate the scalar product A dot B and the vector product A cross B. So we are given two vectors. We have to find their dot product and vector product. So let us move to the solution. So before discussing the solution, let me refresh your memory about dot product and cross product. So if we have two vectors, vector A and vector B, making an angle theta, then A dot B by definition is product of magnitude of A, magnitude of B, and cosine of the angle between the vectors. Remember how we see angle between the vectors? We join their tails and we see the smaller angle. But to calculate the dot product, we can see the larger angle also. That is not going to affect our result, but it is safer to take the smaller angle always, because cross product is affected by the selection of the angle. So join the tails of the vectors, see the smaller angle. That is the angle between the vectors as shown in this figure. So A dot B by definition is a number or a scalar. That's why it's called scalar product. So it has only magnitude, right? There is another way to calculate the dot product of two vectors in terms of components. A dot B in terms of components is ax bx plus ay by plus az bz. So where ax, ay, az are rectangular components of vector A, bx, by, bz are rectangular components of vector B, right? So these are two ways to find this scalar product or dot product of two vectors. Now, cross product A cross B by definition is a vector. That's why it's called a vector product. So if it is a vector product, if A cross B is a vector, so it has magnitude as well as direction. Now, by definition, the magnitude of A cross B vector is magnitude of A, magnitude of B times the sine of the angle between the vectors, right? So this is how we find the magnitude of A cross B vector. What about the direction? Direction of this vector is perpendicular to the plane formed by A and B. So A cross B vector is directed perpendicular to the plane formed by A and B. That means it is perpendicular to both A and B. Now, which way it is oriented? That direction is given by right hand secret rule, right? I'm not going to discuss right hand secret rule. You do it at your places, you know it, and you can check it. So direction of A cross B vector is perpendicular to both the vectors, and which way it is oriented, that is given by right hand secret rule, right? And unlike A dot B, since A cross B is a vector, it can be expressed in unit vector notation. So how we express A cross B vector in unit vector notation? It is written as this. A cross B is AY BZ minus AZ BY I cap plus AZ BY, sorry, AZ bx minus ax bz j cap plus ax by minus ay bx k cap. Let me check it. Ay bz minus az by I cap plus az bx minus ax bz j cap plus ax by minus ay bx k cap. Ax, ay, az are rectangular components of vector A. Bx, by, bz are rectangular components of vector B. So this thing is x component of our A cross B vector. This thing is y component of A cross B vector. And this thing is z component of A cross B vector. So let us move to the problem now. We are given two vectors and we have to find their dot product and cross product. So let us move to the solution of part A first. Let me draw the figure. So let this be my y direction, positive y. This is positive x. And let this be my, sorry, let me draw it neatly. This is my positive z direction. And let this be my figure 1. Now it is said that vector A lies in xy plane and it makes 250-degree angle counterclockwise from the positive x direction. So it is like this. Let me use another color. So vector A is like this. It lies in the xy plane and it makes 250-degree measured counterclockwise with the positive x direction. So this is 250 degrees, right? And what is its magnitude? It is 7.4 units, right? Then we have vector B, which has 5 units magnitude. So it is a shorter vector and it is directed parallel to z direction. So our vector B, let me use another color, is a shorter vector. It is directed parallel to z direction. So this is my vector B, right? So let us move to the solution. A dot B by definition is length of A, length of B times the cosine of the angle between the vectors. So length of A is 7.4 units times length of B is 5 units. Now the angle between these two vectors is 90 degrees. Why? Because A lies in xy plane, B is parallel to z direction. Z direction is perpendicular to xy plane, so B vector is perpendicular to A. It is not visible in this diagram. This diagram is not so neat and it doesn't depict the things properly, but you can understand. Vector A lies in xy plane, vector B is parallel to z direction. Z direction is perpendicular to xy plane, so it is perpendicular to vector A. So angle between A and B is 90 degrees. Cos 90 is 0. So it is 7.4 times 5 times 0. So it is 0. So A dot B is 0 because the vectors are perpendicular to each other, right? So we have done part A of the problem. Let us move to the part B. First, we will find the magnitude of A cross B vector, which is magnitude of A times magnitude of B times the sine of 90 degree. So it is 7.4 times 5 times, as you know, sine 90 is 1. So when you calculate it, it turns out to be 37. So 37 is the magnitude of the A cross B vector. Now we'll find the direction. As always, check the calculation at home. The magnitude of A cross B vector is 7.4 times 5 times 1, which is 37. I will find the direction of this A cross B vector. So let me justify the direction in the figure. The direction of the vector product is perpendicular to the plane formed by A and B, right? Therefore, A cross B vector must lie in the xy plane, perpendicular to B. So it will be like this. I will use this color. So A cross B will be like this. This is my A cross B vector. It will be perpendicular to B. Why so? Let me write here, in the xy plane. Why so? Because A cross B is perpendicular to the plane formed by A and B. So it is perpendicular to A as well as perpendicular to B. So it has to be in the xy plane in order to be perpendicular to B. So it will be, because B is parallel to Z axis. So A cross B therefore lies in xy plane and it is perpendicular to B vector, right? It is perpendicular to B vector. Because when it is, it has to remain perpendicular to B vector, and let me check it first. A cross B vector has to be perpendicular to the plane formed by A and B. So in the figure, it lies in the xy plane. When it is in the xy plane, it's automatically perpendicular to B because B is parallel to Z axis. So one condition is satisfied, it is perpendicular to B when it is in the xy plane. And it has to remain perpendicular to A also, right? Therefore, it will make how much angle with the positive x direction, measured counterclockwise. This angle will be 250 minus 90 degree, which is 160 degrees. And how I have decided it is this way, because of right hand secret rule, you will check that at your places. So I'm saying A cross B vector lies in the xy plane. So it is perpendicular to B. It's also perpendicular to A. When it is perpendicular to A, that means it will make 250 minus 90 degree, which is 160 degree, from the positive x-axis as shown, because A itself is making 250 degree, A cross B is perpendicular to A, so this angle will be 250 minus 90 degree, which is 160 degree. So our solution is magnitude of A cross B is 37. It lies in xy plane, perpendicular to B, at an angle of 160 degrees from the positive x-axis perpendicular to A, 160 degree from the positive x-axis perpendicular to A in accordance with right hand secret rule. Right hand secret rule. Think about it. Think about this and convince yourself. So we have solved with part A as well as part B. We have found dot product as well as cross product of A and B. Now I will give you a little homework. Find A cross B in unit vector notation and find its magnitude and direction. So it is easy. You will find A cross B vector in its unit vector notation. I will give you the answer. When you use the components of A and B to find the A cross B vector, you will get A cross B vector as minus 35i plus 13j, right? This is the unit vector notation of A cross B vector, minus 35i plus 13j. You have to check it. So once you find A cross B vector in unit vector notation, then you can find its magnitude. You know, the magnitude of this vector will be square root of minus 35 square plus 13 square, right? When you find that, you'll see it turns out to be 37, as we have calculated this way. And then you find the direction using the formula tan phi is y component by x component, 13 by minus 35. When you do that, you will see that phi will be 160 degree from the positive x-axis measured in counterclockwise sense. So this is your homework. So this is all for today. Do your homework. Don't waste your time. I hope you are enjoying these problems. And don't forget to like, share, and subscribe my channel. You can give comment in the comment box. Thank you. God bless you. Assalamu alaikum.